This Living Atlas Indicators of the Planet, this is, I would think, a great resource. I've used this at the beginning of, for example, every Monday in class. Hey, let's look at what the status of planet Earth is. It's sort of a dashboard for the planet, if you will. So looking at sea ice, wildfires, climate, weather, natural hazards of various kinds. You get with each one of these tiles a set of infographics that you can interact with, graphs, maps, charts, and much more in 2D and 3D, in this case sea ice. So again, come back to this every week in class period, or assign your students, okay, choose a variable and then report to your classmates tomorrow about why this issue actually matters and the status of this particular variable and what we might be able to do about it with science, with geographic information systems, with people banding together across all disciplines, across all countries of the world. What can we do about some of these situations? Because these issues on our planet do not stop at political, economic, physical, or disciplinary boundaries. So again, a wealth of information. This particular dashboard was created with the Experience Builder. So again, all these tools that I'm showing you, you can actually use in two ways. You can teach content with it, but you can also have students create with these same tools their own reports, maps, etc., that they can report out to you as their instructor, report to their classmates in an oral form, or just to show their story maps or other web mapping applications. So these tools are not just viewable. You can't just view them in one way. You can't just say, oh, I'm going to view content that other people have created. No, you can actually create with these same tools that are all part of the ArcGIS platform that we're talking about. Another Living Atlas app is the Water Balance app. I've got 6 variables at my fingertips. If I look at precipitation, for example, or evapotranspiration, I'm going to look at precipitation. I'm going to click in the Amazon. It's not summer and winter. It's a wet season and a dry season, and I can pan across looking at data that's only a few months old and see when the wet and dry seasons are. And also look at the y-axis. In Libya, as you can see there, there's whole months of the year with no precipitation occurs. So what does that mean for ag? What does that mean for population? What about my own community? How is the trend of precipitation or any of these other variables been trending over the last few years? What about if I look at Southeast Texas? Well, a couple of these spikes are due to massive hurricanes dumping huge amounts of rain in a short amount of time. So you can see some spikes there from some significant typhoons/hurricanes. So again, the Water Balance app, you've got 6 variables and almost real-time data at your fingertips. Here's another resource that I use to find content. Here I'm looking in the Living Atlas of the world. So in the Living Atlas, you've got 8,500 or so data layers. I'm looking for the Esri Hydro layer, and I can open it right up in this case, the new map viewer. You can open it up in ArcGIS Pro as well, or the classic map viewer. But I like the scalability of modern web-based GIS data sets. As you zoom in, you get more and more content. So at the small scale or the coarse scale, I see major rivers, the Amazon, the Yangtze, the Nile. And as I zoom in, I'm getting smaller and smaller tributaries with more and more detail. I also see these dotted lines, which show me watersheds. Fascinating to be able to do this. So I'm seeing watershed boundaries. And then, wow, look at this. At really fine detail, I'm seeing the watershed boundaries, for example, dividing Lake Erie's watershed from Lake Ontario's watershed just outside of Buffalo, New York. And I can see that it's really close to several communities, and some rivers actually cross really close to the watershed boundaries. Now, if I just added the satellite image, it's either or. Either I see the satellite image as a base map, or I see the watershed boundaries and the hydro network. Web interactive map inside ArcGIS Online with some wonderfully rich data layers, as you can see here, global temperature anomalies for different times of the year, for different years, which is inside the ArcGIS platform. You can open it up in the classic viewer or in the new map viewer. Either way, you've got a variety of tools and data sets at your fingertips. In this case, major ocean currents, and specific information about watersheds, for example, Spokane, and how water gets to the ocean from Spokane, Washington. Anyway, warm currents, cold currents, and you see that ocean base map there. It's a wonderfully rich base map. And you can, of course, change the base map to other kinds of base maps. And these features on the map, they have intelligence. That's why they're part of a GIS. They have information behind each one, sometimes animations, as you can see here. You can look at the interaction of ocean currents and prevailing winds. Just an amazing resource. Much more engaging and interactive than a static PDF map. I'm filling it out right now, just like you filled it out when you were out in the field or in the lab. Mapping a storm drain. So I'm entering the time that I collected the data, because in this case, I collected it a couple of years ago, and this was the location of the drain in New Mexico at 33 North, 106 West. It says my data was sent just like you've seen on your screen. I can also open it in Map Viewer. That's our next step. Once we design the survey, we want to actually create a map that the survey feeds. And the reason why is because when you create a map that the survey feeds, that is the map that's going to go into your eventual story map and your dashboard. Now I've got a map, and I'm going to go ahead and open it in the new map viewer, the new default map viewer that rolled out around spring 2021. And I can see that that default base map wasn't quite to my liking. I'm going to change it to an OpenStreetMap base. It's a little busy, I realize, but now I can really see some fine detail, especially since I'm collecting this in an urban area. Obviously, I wouldn't use OpenStreetMap if I was out in the middle of a rural area or a wetland or something like that. I'd probably use a satellite image or even a terrain with labels. Now I can change the style of my points. I've got some fields in here. Where do those fields come from? They came from my survey, which fed a geodatabase, if you will, a feature service. That feature service has geographic coordinates and extent, as you know, the G part of GIS, and it also has a table behind the data, the I part of GIS, and that table contains fields, and you can map on any of those fields. That's why it's important to plan ahead when you're going out in the field. Do we want to collect numeric data? Do we want to collect nominal data? Trees. If we want tree height, do we want the actual height in feet or in meters, or do we want high, medium, and low? It depends on your needs. Depends on, of course, the goals that you've got for your unit. But here I've got a couple of numeric fields. I've got the approximate width, and I've got the condition, which is a ranking. It's an ordinal data, and then the actual width of the drain that I'm estimating is ratio data, so I can make graduated symbol maps like you see right there with a larger symbol for the wider storm drain. I know it's kind of a simple example, but kind of think of the possibilities here, because you can map things thematically by these fields. Wow, that's pretty powerful that you've got at your fingertips, and we've done that in lots of other ways. Population, earthquakes, but even more powerful is to add additional layers to your web map that give something context, give your study some context. In this case, my study is focused on water, so it makes sense that I'm going to look for water-related context here and water-related layers. I've got two main galleries, certainly not the only gallery, but ArcGIS Online and a subset of that called the Living Atlas of the World, which is a 8,500 layer subset of ArcGIS Online. You may say, hey, Joseph, well, if it's 8,500 is a subset, what is ArcGIS Online? Well, it's thousands upon thousands upon thousands of layers of varying quality. So again, see my videos on how to assess data quality. I can look for ecoregions, I can look for watersheds, hydrography, and much more. Soils, population density, and again, the sky's the limit here. Stream gauges. So how did I add these things? I'm just going to adding data from the ArcGIS Online Map Viewer, and I'm showing you how I did this. So now I'm going to go and show you the results. The results of the exercise after I added the map layers are as follows. So now I've got a whole bunch of layers. Remember, more is not always better. Just because you can doesn't mean you should add hundreds of layers. You want to keep it focused. In this case, I want students to look at the relationship between storm drains, rivers, watersheds, current weather, stream gauge stations giving the stream height at any particular time. It's real-time data coming in from the Internet of Things, in this case, stream gauges that are tied to latitude, longitude, and streaming their data into ArcGIS Online. Really amazing capabilities that you have at your fingertips here, folks.